It's like a multi-sided shape. Isn't that what it was?
Okay, so that was going to be a polygon. A parallelogram,
Oh.
yeah, it's going to be a four-sided shape. With two pairs of parallel lines. Also, I can't spell. I apologize. So a parallelogram is going to be a four-sided shape with two pairs of parallel lines. Okay, some ones that you guys have used quite a bit in your youth would be squares and rectangles. But we're going to kind of get into some other rules that go along with the parallelograms. There's going to be four properties that we'll talk about. Biggest thing that I suggest for you will be just to draw the picture of what those properties are. And you can kind of combine most of them together. But the first one is with a parallelogram, quadrilateral parallelogram, the opposite sides are going to be the exact same length. Okay, so this side and this side are going to be the exact same length. This side and this side, exact same length. I kind of explained it using the word opposite. The opposite sides in parallelograms are the ones that are going to be having some pretty good relationships with each other. So opposite sides are going to be the exact same length. Same thing with the angles. The opposite angles are going to be the exact same. So like J and L are going to be the exact same degrees. M and K will be the exact same degrees. Okay, we kind of went through this like chapter 3-ish when we had the parallel lines with the transversal. You guys remember doing that at all? But again, we're going to have those opposite angles that are going to match up, that are going to be the exact same. Anybody need more time on that part? Super. Okay, the next two sets of rules that we have, and hopefully you guys will remember, how many degrees are in a parallel or in a quadrilateral? Four-sided figure. 360. So no matter what, they're going to add up to 360 if we did all four sides. What this rule says, and this kind of goes along with that chapter 3 transversal rule with parallel lines, is that if they are right next to each other, they're going to add up to equal 180. They're going to be supplementary. Because if I did all four sides, they will add to 360. Okay, if we just take half of it, these two angles, if they're on the exact same side, they will add up to equal 180. So like angle J and angle M will add up to equal 180. Angle M and angle L add up to equal 180. L and K, 180. K and J, 180. Again, opposites are the same, but if they are on the exact same side in a parallelogram, they will add up to 180 degrees. No matter what, guaranteed. And then the very last rule is that if a parallelogram has one right angle, just one right angle, kind of based on those rules from before, they are going to have every single angle that will be 90 degrees. So if one angle is 90, they're all 90. All right, I'm going to have a reminder of some terms for you. You good? Reminder some terms for you and kind of how we draw some things. Remember, if you have like the red arrow, like the carrot looking thing, kind of pointing sideways, those represent parallel lines. So like if I just had the one caret here, these two lines would be parallel. If we do 2 of them and 2 of them, those ones are going to be parallel to each other. It can also be expressed by having like a filled in triangle. Usually it's going to be red. So that's going to be the drawing portion of it. Also, if you see the 2 lines straight by each other, that also shows you that they are going to be parallel lines. So the way I have this one written is that line AB, this one right here, is parallel to CD. So that's why I put those little triangles on them. Line BC up top and AD are going to be parallel to each other. So that's why I put those 2 little carrot looking things. And then again, follow those same rules of opposites. Angle A and C are opposite of each other, so they're going to be the exact same length. And then angles B and D are opposite of each other, so they'll be the exact same length as well. Questions on that stuff? Okay. Don't worry about these other little notes I had. I kind of talked about it with the X and the Y's, but no matter what, if they are next to each other, the 2 angles are next to each other, they'll add up to equal 180. Okay. Real world examples. All right, so for my real world example here, I've got a set of stairs and there's a railing on the side. Okay, on that railing, they've got the 2 poles on each side. They're going to be going up perpendicular to the ground. So they'll be going perfectly vertical. If they're both vertical, that means they're both going to be parallel. And then you can have a railing that's going down on the side as well. Okay, you got the top part of the railing, so that way people can hold on. You got the bottom part of the railing to keep kids from falling off the stairs. So we've got that shape on the side. We've got this rectangle over here. I'm going to redraw it, and we're going to solve every single part of that one, just to kind of verify all those parts themselves. Okay? We already kind of mentioned it. Let me get a different color so I can show you the parallels and all that fun stuff. So this was A, this was B, this was C, and this was D over here. Okay? Remember, these ones are both parallel. And then these ones are going to be parallel. If those are parallel, this line segment here is the exact same line segment of that one, or length of that line segment. Line segment A and B. You will have all day tomorrow to work on that. These ones are both going to add up to be, or they're going to be set to equal each other. So it'd be 3x, or sorry, 3z minus 4 equals z plus 5. Okay. Perfect. Perfect. Awesome. All right. And if you just really want to get after it, every single one of those goes in a Google Classroom. You do it at home. You do the whole week. I will never do it at home. All right, so I've set it up. For those people who are still working on it, I will kind of work through it with you. So I've got 3z minus 4 equals z plus 5, so minus z to both sides. I get 2z minus 4 equals 5. I'm going to add the 4 to both sides, plus 4, plus 4. 2z equals 9. Divide both sides by 2. Z equals 4.5. Okay. I like what I saw. Questions on that part? Okay, this one is just showing you all the things that could be in here. I'm going to do these ones with you. It's just showing all the things that could be in here. Okay, we've got opposite sides. Okay, it's telling us what each one of these ones are, so we're going to have to use diagonals to figure out what they are. And then we also are going to have that midpoint. So I'm just going to show you through the 3 different ways that we do it. Okay, so if I'm going to start with the first value of an R. Okay, R is my first letter. So if I've got 4R right here, what side or what number matches up with that?
18.
Perfect. I got 4R and 18. They're opposites of each other. So we're just going to set them equal to each other. Again, if they're opposites, we will set them equal. So I've got 4R equals 18. Divide both sides by 4. R equals 4.5. Okay, the next one. So I did my R. I'm going to do my S next. S. I'll use a highlighter for that one. Here's an S. Here's an S. Yep, perfect. They're both going to be on opposite sides of that midpoint, so I'm going to set them equal to each other. So I've got 7S plus 3 equals 8S minus 7S minus 7S. I get 3 equals S. That's my answer. My last one, I'm going to have my value for T. T's right there. For T, T is this angle up here. Remember, with that transversal, it's going to be the angle that's on the opposite corner of it. So what angle am I going to use?
18.
Perfect. So I've got 2T equals 18. Divide both sides by 2. T equals 9. Feeling good? Here's the part where people hate me. I wish I could have recorded the faces that you had when you saw it. Okay, I'm going to explain this one because there will be 2 of these ones on the assignment. And I'm going to kind of show you what we're looking for. It says, what are the coordinates of the intersection of the diagonals? So where both those diagonals are going to come together. So I'm going to write these ones down to show you what the shape is going to look like. My first point is going to be at -3, 0. So my first point is going to be there. That'll be my M. My next point is going to be at -1, 3. That'll be my N. Next point will be at 5, 4. That'll be point P. And then 3, 1 is going to be my next point, and that'll be point R. Okay, let me get a different color so you can see me drawing these lines together, roughly. Okay, that's kind of my outside. My diagonals that go across will be here and here. I want to find out exactly where they cross. Yes, I did my picture, and you should see pretty much where it's at, but I'm still going to do the math. Any guesses on what formula or what sort of thing we will do to try to figure out where the middle point is, where that midpoint is at? You could do slope.
Midpoint formula?
I would stick with, yeah, I go with midpoint. But yeah, you can do the slope and then you can do distance. You can try doing that. You can do the distance formula and do some other stuff that goes along with it. Or yeah, I'm just going to stick with the midpoint formula. Okay, so if I have the midpoint formula, who remembers what the midpoint formula was?
X1 plus X2 over 2.
Perfect. And then my y value would be y1 plus y2 over 2. Because again, we already found out that in between this line, the middle of it, it's going to be bisected, be cut perfectly in half. So as long as I choose those 2 outer points, the ones that are opposite of each other, I will find the exact midpoint. So looking at that shape, I'm going to zoom back in a little bit. Sorry if you're writing that one down. I'll do this so you can still see both of it. Looking at this shape, what letters do you think can we choose to find where the midpoint's going to be at?
You're going to do like N and R.
Okay, I can do N and R. Perfect. I will do N and R because these ones are going to be opposite of each other, and it's going to go across. So I'm going to go through what those points were. Point N, my X value is going to be -1, plus my R value is 3, divided by 2. God bless you. My N value is going to be 3. My R value is 1, divided by 2. So simplify that stuff down. -1 plus 3, divided by 2. My first value is going to be 1. Again, I'm kind of doing all the math either in my head or on a calculator. 3 plus 1 is 4, divided by 2 is 2. So when I chose N and R, I'll say that, just kind of show you what we did. With N and R, my midpoint's going to be at 1, 2. So I go over 1, up 2. That looks like we did it right. What if we chose 2 other letters? What other 2 letters could we choose? Perfect. P and M, the other 2 kind of opposites. I'm going to grab a different color just to show that you could have chose those other 2. Okay. The P and M, I could have -3 plus 5 over 2. The next one would be 0 plus 4 over 2. -3 plus 5, that gives me a 2 divided by 2, that's a 1. 4 plus 0 is 4, divided by 2 is 2. I get the exact same midpoint. So it doesn't matter which one I choose. I can choose these 2, I can choose these 2. It just has to be the 2 opposite points. Okay? When you're trying to figure out which ones they are, you do not have to graph it to scale, but my suggestion is going to be to put roughly where the dots were at. So like this one was like, all right, -3, 0, about there. Next one was about here. Next one was here-ish. Next one was here-ish. This way I can see which ones are opposite of each other. Does that make sense? Again, this stuff doesn't have to be drawn to scale as long as you can figure out which ones are going to be the opposite points. Okay, so for that one's going to be the midpoint formula. There will be some later on that may use the distance formula. Who remembers the distance formula? Last thing I'm doing is just showing you the formula. We're not solving it. Kinda. I'll start slowly drawing.
Like x minus x2 squared.
Perfect. Okay, this is the distance formula. If you forgot about it, that's the distance formula. Otherwise, this is the midpoint formula. That's it. That's all I'm going over today. Tomorrow is going to be an entire work day. I think we have, 2 minutes left? Maybe?
4.
We got 4 minutes left. So if you want to get started, by all means, you may. But what we're working on all day tomorrow is to be that 407 and 408, 9 through 12 all, 15 through 22 all, and then 31 through 36 all. But again, you'll have all of class period tomorrow, so all 42 minutes. But yeah, otherwise I'll put it up on the board tomorrow. Thanks for being attentive.